Next law of exponents is called the power to a power law. So when you have that bracket, this means a to the power n is being taken to the nth power. Then we are going to times it. Okay, and I'll show you why in a moment. If we look at 2 to the power 3 to the power 5, that means we have 5 of those 2 to the power 3's being times. 1, 2, 3, 4, 5. Oops, I forgot the 2. Then we know from our previous property that when we have same bases being times, that means we are going to add the exponents. So we have a 1, 2, 3, 4, 5 threes to add together, which is 2 to the power 15. Okay, so similarly, when you see that bracket between the two exponents, we know it's to the power, and we are going to times. So it's 2 to the power 3 times 5, which is 2 to the power 15. Similarly, in the second example, okay, we only have the one base. We are going to times each of these exponents. Also very important when we're working with brackets, we work from the inside out. Yes, like the movie. Okay, that's what our BEDMAS tells us to do. Our orders of operation. So 2 times 4 times 3, same, and we know 4 times 3 is 12, times 2 is 24. Then product to a power. That's when we have things being times inside of the bracket. Okay, remember things are being written next to one another like this, variables or number and variables, it means times. When we have a product to a power, it means that power on the outside is going to be times with every exponent on the inside. Okay, so in this case it was 1 and 1, but it could be other exponents also. So for this example, we're going to have each part of it to the power 5. Negative 3 is being taken to the power 5. A is being taken to the power 5. B to the power 5. And C to the power 5. Okay, we get everything. Then we know negative to an odd power is always going to be negative because they pair up, and then there's that odd negative still there. Then we have a 3 to the power 5. And then we just know a to the power 5, you can drop the brackets, or you see it as 1 times 5 is 5. And that will be the case for all of them. And this is one answer. You know, everything is a product there. You can't simplify it further. Another example, everything again. So the 2, the x squared, and the y to the power 3. Everything is being taken to the third power. So, as we said, everything is being taken to the third power. You go copy and paste and put everything to the third power. 2 to the power 3 is 8. Okay, but if they say leave it in exponential form, you can leave it as 2 to the power 3. But it's always better to change it. Then x, 2 and 3 we are going to times. So 2 times 3. You see it's only exponents being times. We did not say 2 times 3 is 6. This is 2 to the power 3 is 8. Okay, and y 3 times 3. So we have 8x. 2 times 3 is 6. See, because it was exponents. And 3 times 3, yes, is 9. Okay, please do not write 6 for me again. Then our last property. This is more of like a property than it is really a law, because it's derived from one of the other laws I'll show you in a moment. But a zero power property or law. Okay, where this comes from is anything divided by itself gives you 1, right? So if you have y to the power 5 being divided by y to the power 5, we know something divided by itself is 1. But our same basis being divided law tells us we subtract, right? So this is y to the power 0. But we also know it's 1. Okay, so anything to the power 0 is 1. Anything to the power 0. It doesn't matter if it's a number, if it's a variable, if it's a whole bracket with all these things happening inside of it. Okay? If it's to the power 0, your answer is going to be 1. You are not going to waste your time trying to simplify what's inside the bracket. So, 5 to the power 0 is 1. A whole bracket with like 5x plus x minus y, whatever, to the power 0, 1. then even if there's a whole thing happening and then there's nog 'n bracket and there's a thing happening, what if 2 power 0, 1.